Thank you for the introduction. You guys can hear me all right? Cool. Yeah, I work at Imager and giving a talk today about how we count our image views, which is obviously a pretty huge number at Imager. We use Redis cluster in our new system to scale up to roughly 3 billion writes a month. So the alternate title for the talk is How We Learned to Stop Map Reducing. So this is a picture of our infrastructure in 2013. No, this is actually a picture of how many view counts. This is a pretty viral image from 2013, getting roughly 500,000 views. But obviously we're sort of accelerating that. So this is a 3-day-old image with more than that number of views. And this is actually a video. So we're growing, we're getting huge numbers of views all the time. And if you look there, like pointing out that the actual little feature that I'm talking about today is simply the storage of an accumulation of this number here. So yeah, we do just about 3 billion writes a month, or 3 billion image views. The reads are sort of unknown. It's too much to count. So this is our previous implementation of the view count system, which should be fairly familiar. It's sort of the obvious go-to. Essentially, our CDN ships us giant access logs, sort of Apache access logs, and we have a MapReduce job through Apache HBase that will collect all these logs in batches and go ahead and increment these counters. We did actually, you'll see, have Redis in this initial system, and it was just basically to buffer views from the HBase system. So it was sort of problematic, the HBase cluster, and so we popped Redis in front. And this sort of led us down the path that I'll talk about as we go on. So unfortunately, this design has a couple big flaws, not so much due to the technologies being used, just the nature of the setup, both because of S3, because of MapReduce, and because of the delivery of these large chunks of logs, you have some delay. So we would get the log files, I think it was about every 10, 15 minutes. Sometimes they come faster, sometimes slower, it just depends on what the CDN was doing behind the scenes. And that obviously changes over time. But we also had some failures. So we had some failures on Zookeeper, we had some failures on HBase, and this isn't so much a product of HBase or Zookeeper, but more just where our expertise lie in the company. Like I said, we've already sort of plugged Redis in here, and that's really one of our strong suits. So it's sort of part of our boring stack. We love Redis. So I wanted to put a slide in here that showed it's not so much about comparing HBase or Hadoop or Apache versus Redis. It's just that it wasn't really our wheelhouse. So some memes from Imager for you. One of the big challenges with HBase is it speaks Thrift. We have a PHP library speaking Thrift. None of these things were exactly bright and shiny, brand new technologies. So there was sort of a constant low level of failure. Thrift, if you guys have any experience with it, has just about as many tunables as there are human beings on the planet Earth. You can sort of deep dive into that for hours and hours and hours, and boy, did we do that. So we had some success there, but the big problem was when it was fully down, you'd actually get about 5% of requests through. So it would never really fully die. It would become degraded, really heavily degraded. And when it was working, that top graph, about 5% of all requests would fail. So this made it really, really, really hard to design circuit breakers. As you know, traditional sort of circuit breakers are like, okay, the system has come back on, let's send it a few requests. And if you're constantly failing a small amount, or you're constantly succeeding just a small amount, you can sort of spend days and days and weeks building those circuit breakers, getting really fine-grained. And we did that, but it was sort of diminishing returns. We would still have pretty huge issues when there'd be a fatal HBase issue, cluster issue. And obviously, when HBase is down, Imager would go down, and we're the ops team, so we would be very sad people. So we sort of worked with this database. We're not the kinds of people to sort of wholesale replace something because we want to go to something else. We try to be pragmatic, so we did try to tune this for quite a long time, and it just became untenable, became a bit of a time sink. And like I said, we're just growing and growing and growing. So these problems are slowly getting worse in sudden, brief spikes, as you can see by the last graph. So the solution really was to continue using the technologies that we liked. So that Redis cluster, or that Redis instance in the old system, we never had failures there. That view count was just a cache. It would basically, if we got a read from HBase successfully, we'd set it with a small expiry time in this Redis instance. If it existed in the Redis instance, we didn't go to HBase, and that saved us a pretty huge amount of reads, particularly for the really viral images. But of course, you're also introducing delay. So whatever expiry time we had on a key in Redis meant that users weren't seeing the updated view count because obviously they were just reading a cache. However, we were into Redis. It worked beautifully. It didn't really fail. So we decided to go with pure Redis as our ultimate solution. Our key space is far too large, though. We could never put it on one box. So Redis cluster was sort of was the fix there. So our new solution relies on a very cool feature from our CDN Fastly, and other CDNs have started to release these features as well. I think CloudFront does it as well, where instead of batching the logs to some storage and sending you a big giant file full of Apache Access logs, it actually just makes a TCP connection and streams you syslog. So it's the same stuff, just coming over an established socket. This is really, really cool for us because then essentially we can count views as they come in. Especially if we're using all Redis, we know that there's no MapReduce system. We're simply just running increment. So we need something to speak syslog. So we wrote a little microservice in Node.js. Essentially, all this service does is it parses the syslog stream. It handles a TCP connection. It does a little bit of logic around how we count thumbnails, how we count videos. Videos come in as like a stream of chunks, so you kind of need to do some logic there. There's a little bit of logic there, but really I would say maybe it's a 150, 200 line piece of code. So it's very, very small, very maintainable. And everyone in our company writes JavaScript, so that was pretty straightforward. Behind that, it writes to the new Redis cluster, which we've had a ton of sort of great experiences with. Like I said, Redis so far has basically been the one piece of our infrastructure that never fails, or when it does, we know really how to fix it. So this is great to have essentially our cache layer. What was our cache layer is now our source of truth. We also have the old HBase infrastructure, so we wrote a little backfill service. Logic's pretty straightforward. Scan over every single key. If the value is greater in HBase, then write it to Redis. So again, probably 100, 200 lines of code. It's kind of glorified to call it a service. It's basically a script. We're sort of Linux-y types, so we don't over-engineer if we can possibly help it. And then we wrote another API service. So all three of these are essentially one code base. It's basically one Redis driver. We use the high Redis C driver from Redis.io, which is super highly performant. Obviously, Node.js is not ultra built for speed, but we wanted to be simple as possible and get this done really, really quickly. The other thing about this is this was all built by our ops team. So we didn't have a lot of the overhead of complexity of sort of asking our developers to take extra time out of their day or out of their sprints. We wanted something really dead simple. The API service is exposed for two reasons. One, obviously, we wanted to put this on the internet so that apps, future programs, API users, et cetera, could access the view counts directly. If you have the hash of an image or an album from Imager, you can get the count. Additionally, it serves as a layer for legacy clients. So the big Imager logo there is our legacy PHP code base, which doesn't have the greatest drivers for Redis cluster, although that is changing as time goes on. But at the time, with the version of PHP we were on, and Redis cluster being fairly new a couple months ago in PHP land, we felt a little bit better having a layer there with some technology that we really, really trusted. So this is a little preview of what it looks like. I don't know if you guys can see it too well on the screen there. Maybe I could blow it up for you. But the idea is that this is simply a little grease monkey, or whatever grease monkey is called now. I can't remember what they changed the name to. Just curling that endpoint over and over and over, asking for the hash that I'm looking at. And this is not doctored in any way. I'm not incrementing the number. I'm actually just asking Redis cluster, hey, what's the value of this key? Just doing a get every single time. And on the back end, that number is actually log lines coming in from our CDN. So it's truly real time. I mean, maybe there's a little bit of delay. One of the side effects of this system when we designed it was kind of interesting. A couple of users had feedback. A couple of my friends who are using the site would say, hey, I'd post an image, a private image, unlisted, not to the community, for myself, and it has one view. Who's looking at this? And then they'd refresh. well, it has 2 views, what's going on? I think it's people aren't used to real-time stuff. They expect some level of delay, some level of filtering. This is literally how many gets the image gets. Like I said, with some caveats around thumbnailing. So the best numbers for us, I mean, that's a cool feature. We like that, but that's not actually what you'll see if you go to the site. We don't just continuously slam an API over and over every second. I mean, maybe there's some room to make a WebSocket or do something fancy, but in reality, we just get that once every time you load the page. But for us, the more important numbers are the load testing results. So that's doing, I believe that's 500 simultaneous up to 10,000 requests this is to the Node.js API. So this is actually really impressive numbers when you consider this is 2 services, and these are distributed across 3 access zones in Amazon. So we land on a Node.js service, we go to Redis cluster, we get the key, and the minimum latency is obviously pretty impressive. 1 millisecond is really awesome. But that max latency, I think, is where Redis really shines, particularly the 99th percentile. In the worst situation ever, this is not really slowing us down. Even when Redis is sort of doing a background save, doing an AOF, when you're sort of transferring data around, we've really pushed the limits of how badly we can get Redis to perform, and it doesn't perform badly. So that's a really great number. Leads us to the numbers we really care about, which is our sort of success rate. So that's the total number of requests divided by the number of codes over or equal to 500. So that would be like any kind of gateway timeout, any kind of server error, any kind of Redis exception. So there's our 4 nines, which is the big number we cheer about over an imager, and our response time, which had dropped significantly after rolling this system out. Some stats on the Redis boxes. We actually have migrated this Redis cluster quite a few times, not really for Redis reasons, for resizing the box on Amazon, to get new kernels, to do sort of the usual database upkeep that in most databases you just don't do. For instance, with our HBase solution, they were on extremely old Amazon systems, mostly because migrating HBase clusters was really painful, sort of an unknown with the old version of HBase we were on. So you'll see that not all those commands process numbers are equal. The reason is because we're rotating in new Redis clusters, instances all the time, we're resharding a lot, we're sort of experimenting with how that works in production. And then over there, the amount of memory. So I think it was 418 gigs last time I did the math. We have a ton of keys in memory. So it's good or bad depending on your perspective on these things. It's good because that means every single image that's ever been on Imager ever is going to come back in like 2 milliseconds. You're going to get that view count. It's bad because obviously 400 gigs of memory isn't the cheapest thing in the world. So we have some strategies on that, but I'll talk about that in a minute. Some of the sort of gotchas, and these are smaller gotchas than any other database system I've ever really worked with, have to do with the shard map. So when Redis cluster, the way that it works is that each node essentially contains a map of where all of the keys live. They're CRC'd, so essentially there's a consistent hashing algorithm that takes that key and assigns it to a number. And then that number lives somewhere on the cluster. So if you have 4 servers, you split up your keys into 4 sort of shards, which is 4 sections. And your clients, when they boot up, get that map. And they use that map to figure out, okay, you're asking for key A, that's on server A. Key B is on server B. When you migrate shards around, when you migrate things within Redis cluster, not all clients are written to the same level of intelligence. So some clients need to have some extra love, and it turns out with the Node.js library, this is the case. You essentially need to control, if you're getting a lot of redirections, if you ask a Redis cluster, hey, I need this key, according to my map, you should have it, and it replies to you, sorry, that key's been moved, it's over here now. You do need to have some code that basically handles that situation and gets your code base to get the new map. Obviously, can't be that naive because getting the new map every single time a key has been moved while you move 100 million keys becomes a huge issue. So there's some trade-off and design nuance there that we're still trying to figure out. We're ops though, so when things behave badly, we just restart them, which is honestly really great in this situation because you restart it, gets the new map, boom, you're healthy again. Your rate of redirections goes right down. So it's pretty much a no-brainer. Somebody who has no experience with the system, who's on call late at night, who didn't build this system can go, oh gosh, this API is starting to get a little slow. Let me just roll out some new ones, or delete the old ones, or reboot the existing ones, and boom, it's magically fixed. Not the greatest solution, but at least it's as pragmatic as possible. You certainly can't do that with a Zookeeper instance. AOF is, obviously we want to save our view counts, so we have replication, we have slaves, but we do want to save them to disk and do backups and do offline analysis, do all these things. AOF is the append-only file. It's how Redis saves its sort of log of transactions. If you have that enabled while you're moving 80 gigs of data between servers, Redis trib, which is what we use, sort of the official, well, quasi-official how to manage your Redis cluster script, that can actually sort of fail out, and the cluster can enter a down state where it thinks that there's a shard misallocated. And that, unfortunately, can play havoc on, or can wreak havoc on some of the clients, which say, hey, the cluster's down, I'm not even gonna try. Right? It doesn't get more pragmatic. So some modification of the clients to be more pragmatic, to say, hey, ignore the cluster down, go get me my key, and some sort of operational practice around how you use Redis trib, disabling AOF before you do migrations is really important. The third thing I already sort of touched on, not all clients are created equal. There's a lot of great work going on to improve the PHP 7 Redis cluster library. And it's gotten much, much better. And in fact, we're sort of experimenting if we can switch back to that. But we did end up building an API for our legacy systems to talk to, so that you can simply curl and get the data you want and display it. Overcapacity behavior is not really something to be aware of, but it's a trade-off in all databases. So if you run out of memory in MySQL, the sort of the world ends. If you run out of memory in HBase, the whole world ends, certainly. If you run out of memory in Redis, assuming you've set a max memory policy, you just lose the least important keys, which for us is essentially a huge collection, gigs and gigs and gigs of one view private images that people have uploaded. So obviously we don't want to drop keys. We alert on that, we monitor that, we expand when it comes, and we have yet to drop a single key. But we like this design because if we were to drop keys, if we fell asleep, if the whole team got hit by a bus, and everyone forgot about their system for months and months and months, most likely no one would notice that their 1 went back to a 0. So we like that sort of design. But there are some things we didn't do. So we, like I said, at Imager, we sort of pride ourselves on pragmatism. We're a really small team. We try really hard to think about what is worth our man hours. And we sort of tend to think that the price of compute will always be going down, and the price of really good experts in the area will always be going up. So we try to optimize, or at least I try to optimize, for simplicity of design. So because of that, I sort of went out of order here, but because of that, our key layout is extremely, extremely naive. It's literally, if you go to Imager, you'll notice that every single image or album has a random hash associated with it. It's literally that is the key, and the value is a number, and we increment and we get. There's only 2 operations involved. So that's not great for memory, obviously. We could take the first 3 characters and use a hash to set the last 3 characters. We could use a bit field. There's a number of cool options in Redis to make this more clever in terms of how much memory we use. But again, I didn't want to have to say, oh, hey, you want to access view counts? Go ahead and do this consistent hashing algorithm on your key, find the offset, do some math, then go get your bit field offset. I didn't want to have to write a guide for this, right? So it's much easier to just say, hey, you want to count? You get it, right? So we're trying to decide if that's worth our time. Number 1, I already talked about, pretty complex to get PHP, especially PHP FPM, to directly talk to Redis cluster. There's just some sort of architectural issues there. And then the third one is a byproduct of Fastly, of our syslog stream. So instead of there being giant files delivered to S3, which you can consume in a MapReduce setup, and you can in parallel do all this big data goodness, you have one connection, right? One connection lands on one processor on one network card. So that poses some issues, particularly for Node.js. So it is entirely possible to design a system that cannot handle the load. And it's not because you're not on a big enough machine, and you don't have enough memory, it's because you're pegged on one core. So we're looking at something like maybe Rust or Golang might be worth our time to lower the load a little bit, Turns out this hasn't been an issue. Every once in a while you update the new version of Node, you get the newest version of the Redis library, load goes down. So we're not super worried about that. And it's possible that at some point our CDN will decide to give us 2 streams instead of 1, and we would be very, very happy. But yeah, so that might be a good use case where extra manpower gives you a little bit of worthy performance. So at the end of the day, the results from this, this whole project is that we reduced the site response time by 50 milliseconds. Before we were at like, I don't know, we showed that graph, we're at 75. We're a little bit over 100 milliseconds, and we really wanted to get that down on average. Looking at the sort of the gamut of what our system spends its time doing, getting that one integer sort of pained us that it was so slow. And again, we were already using Redis as a cache, so this felt really natural. Hey, we know this technology, let's just put everything in cache, right? It actually turned out to be quite a lot cheaper. So I was a bit worried about this when we were first designing the system, just simply because of keys and memory. HBase has the ability to flush to disk. Felt nice. In your sort of heart of hearts, you're like, who has that much RAM? That's a bit ridiculous. But at the end of the day, assuming we can upgrade to the newest EC2 instances without issue, which was the barrier with HBase, is the ability to iterate, to bring out new systems. Using the newest type of EC2 instances, reducing the MapReduce cluster, getting rid of the Zookeeper setup, we reduced costs by about 75%, which was way bigger than expected, but quite nice. And then the thing I care about the most is the simplicity. So at the end of the day, there's very little about this to explain to somebody. I can show them the 3 folders in one repo, the API, the ingest service, and the backfill, which is no longer needed, the backfill. They can read the code in less than a day, maybe an hour or 2. It's pretty straightforward. Node.js and Redis, not a lot of mystery involved. Those are pretty well beaten paths. There's no Java, there's no MapReduce, no third parties. We had a vendor for our HBase setup, which was of varying quality. Zookeeper, I've destroyed many a Zookeeper clusters. I don't know if you guys have, but it's always frightening. And then even inside of Redis, we're literally only using 2 operations. So it feels nice and simple. And then the biggest advantage is obviously I got to talk at RedisConf. So that one's pretty good. So I wanted to give some acknowledgments. I'll talk a little bit more if you guys have some questions. I think I have quite a bit more time left. But I wanted to thank the DevOps team and the platform team. Our platform team is awesome. They sort of allowed us to build this. They said, hey, we got other things to do. Do you guys want to do it? And we called their bluff and we made it. So we sort of think of it as a nice DevOps project, right? It's not terribly interesting, but it is sort of vital to the infrastructure. And it's really about keeping it as simple as humanly possible. So I think of it as a good DevOps project. There's a lot to go over here, and I kind of sped through it. So I don't know if you guys want to do some questions or if there's any sort of parts I can talk about.
You mentioned in your slides that you use the RedisTrib utility for your management. Has that been a pain point, or has it worked for you? Have you considered things like the Python port of it or the Crystal binary to do it?
Yeah, so we've only actually been using RedisTrib. It has worked as well as it should, I suppose is the way to say it. It definitely does its job, and it definitely, we put together some scripts. So for instance, if you run a rebalance and the output of the rebalance is cluster down, then immediately run a fix on the node that says it was down. But that's sort of to our liking. We like tools that do one thing, especially really simple command line tools written in something like Ruby that we all know. We're a pretty big chef shop, so Ruby's right up our alley. So I would say, yeah, we've had really great experience with it. We have not tried any of the other systems, although we're keeping our eye on a couple of them.
As a quick follow-up, do you guys install the tool on each of your local machines? Or do you use like a jump box or have Ruby installed in every single cluster node, for instance?
So yeah, so in this case, our infrastructure is provisioned with Chef, so we already have Ruby everywhere. So we just run RedisTrib on the boxes themselves.
This is kind of a recurring theme. I've asked this question in other rounds. Do you guys have to deal with, I actually have 2 questions, both brief. You have to deal with hotkeys? Do you have any hotkey issues with cluster?
Yes and no. I mean, sort of the principle of Imager itself leads to extremely hot keys and extremely cold keys. But Redis handles that really brilliantly. We've basically never had above a 1 load on any of the Redis servers. I think we have 6 right now. So while there are hotkeys, since it's only git, And there's really no caching, like there's no caching even on the CDN, on the node layer. It's directly to Redis. We've had no issues whatsoever. So that might be a thing in the future. At some point, we'll be doing lots of requests. But the nice part is our keys are totally random. So you do land equally among the 6 boxes. So yes and no.
Great. And my second question was, have you looked at Redis as a PHP client? You mentioned some problems with the other PHP.
Yeah, we've been investigating, pRedis, and then the official Redis client for PHP 7 now does support cluster. And at the time that we built this, which was a few months ago, 4 or 5 months ago, that was sort of brand new. So we didn't go down that route. We already have a lot of PHP code that deals with retrieving from a microservice, an HTTP microservice. So we just sort of plugged that in. One of our moving forward mottos is to try to write as little PHP as we can. So yeah, but that is eventually something I want to work on.
So you mentioned reducing complexity by moving to this model, but it looks like you still have some complexity in the backfill service.
There is some complexity in the backfill service, although we designed the backfill service fairly pragmatically. So it literally, HBase has a scan functionality, pretty similar to Redis's. So we basically say, okay, every key starting with lowercase a, scan through it. If it's in Redis cluster and it's lower, then set that number. So earlier here I showed that we have like 5% failures all the time. That backfill service had to be run over and over and over and over and over. Because at a certain point, if you can't get the data, you can't get the data. So just Node versus PHP didn't really help getting data out of HBase. So that backfill service did, I think, run maybe 10, 15, 20 times just on a loop until one day we logged into it and saw that, hey, it's basically restoring close to 0 keys, at which case we sort of turned it off.
Okay, so at this point, it's not part of the architecture then? Or?
Yeah, exactly. At this point, actually, the HBase infrastructure is all removed.
So what happens in a, how do you restore view count if in a disaster in that case? Right.
So one thing I actually didn't really talk about here is our Redis cluster that much, actually. Whatever slide, this one, boom. So we do use AOF on the Redis clusters themselves, and we take occasional snapshots of those AOF files and save them, which is of varying usefulness. And then we also have slaves off of the Redis boxes. So we have yet to deal with an actual hard node failure. To some extent, the HBase didn't suffer from that either in terms of Amazon didn't turn off our boxes. We got sort of lucky. But the software was on the failing side. So on the Redis situation, we have not yet dealt with it. In the case of Amazon saying, hey, we're going to decommission this box, it would be fairly straightforward to add a new slave and cut over. So. Have you simulated failure recovery? Yeah, so we did simulate restoring an AOF file from sort of our backup storage, and we have cut over to a slave. So every time we expand the cluster, we do it by building a slave. So yes and no. Thank you. Not while sweating.
So actually, that was my exact question as well, but I'm curious, so right here. What would you like to see happen in Redis cluster next, or what was the biggest pain point for you, something you'd like to see there be work done on? So I've been thinking a lot about this, and I think the biggest one is on the client side. Redis cluster itself is actually pretty great. I do love the simplicity. I like that there's not much inter-cluster communication. It's literally, there's a map. The map leads you to where you need to go. The work that can be done would be on the clients. So for instance, I've got this Node.js service that reads from Redis cluster, the API service here and the ingest service, and those always need to know where the keys live. Any level of redirection ends up causing latency. And obviously latency is really bad when we have this sort of blocking API, the PHP API requesting it. It needs to be really highly available. So if there was a way to say to the client, hey, if I get a move, remember where that key has gone, or even better, a Redis pub sub mechanism is what I've been thinking about, where if Redis trib is saying, hey, here's the new map, as soon as it assigns that map and finalizes it, essentially, while you're migrating keys, the map is unchanged, and when the keys are successfully copied, the map changes and the old keys are deleted. In that time, Redis trib could easily publish a message to a channel and say, hey, there's a new map available, and here it is. Which would be really great if the clients could then consume that map, and basically you would never get a key redirection. That would probably add a lot of complexity to the system as it exists. But it would be nice to have a sort of no-brainer way of doing migrations without having to know what your clients, really the inner workings of your clients. Oh, an official multi-threaded version would be really great too of the Redis trib utility.
Have you thought about the future for those, let's say you have a really cold key or billions of cold keys, instead of, and let's say memory becomes expensive then, do you have any thoughts for the future about ideas that you might do to, I guess, take it out of memory and put them on disk, but still have them potentially accessible?
Yeah, that's a pretty hard question. When we were originally designing the system, one of the requests was, is it possible we can store the date, like a timestamp of the last view? And when we looked at it, that would be the vast majority of all the memory used, would be storing that date. So it sort of becomes like, what side of the problem are you solving for? If you bloat the memory space so that you can reduce the memory space, it just becomes a hard math problem. So we let off on that. I do think there's a potential so for instance, something like Cassandra, there's a couple other databases that do feature like flushing to disk based on an LRU kind of algorithm. That would be kind of nice. If there was some functionality in Redis, I've worked at many companies, thankfully no longer the one I'm at now, that uses Redis swapping on disk, disk-based storage. If there was a way to say, hey, I've got this swap, you can LRU onto that, that would be a pretty interesting mechanism. But from our perspective, if we did, once we get to terabytes of keys, essentially it'll get to the point where we do want to use something like Bitfield or hashes. Bitfield, we have a consistent length hash. We can just sort of calculate that as a number and move over and find the number we want. Obviously, Bitfields don't support incrementing in the same ways that normal numbers in Redis do. So there's some additional complexity, and we can't really, at least I can't decide, is that worth the man hours versus just paying the Amazon bill? Hard to say. At some point in the future, that would be a really cool project. You hire somebody and say, hey, reduce the memory usage. So I'm not going to ask the Redis lab guys, though, add disk flushing. That would be just a minor feature to add.